Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. An oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane, as well as the vertical plane. Now, due to the inclination of the oblique line with the two reference planes, so the neither of the front view or the top view, they will be parallel to the XY reference line. And the projections of the oblique line on the horizontal plane and the vertical plane will reveal its apparent length, and we will not be able to obtain the true length of the line in the front view or the top view projection. So in case we require to obtain the true length projections of the line alongside the true inclinations of the line with respect to the two reference planes, so we need to use the principles of rotation of the line in order to evaluate the true length and true inclinations of the line. Now here we have got a real life situation into which we have been provided with two objects, object A and object B. There are two mangoes available on the opposite side of the wall. So here we have got a wall into the garden, and these two oranges, they are available on opposite sides of the wall, and we have been provided with the coordinate locations of these 2 points or the objects which are available with us into this situation. So as we look at this particular tree from this side, that is, this is going to be the front view. So the horizontal distance between the vertical projectors of point A and point B, this distance happens to be 2.5 meters. That is, the distance measured along the wall in the front view happens to be 2.5 meters. Now, in order to locate the location of point A or the mango A over here, so this mango A is located 1.2 meters in front of the wall and at a height of 1.4 meter above the ground. And here we have got this wall which is having the thickness is equal to 0.3 meter. Now the mango B or the object B, so coordinates if we have to locate, so we can find that the height of the mango B or the object B, it is 3 meters above the ground and it is 1.6 meters on the other side of the wall. That is, it is lying 1.6 meters behind the wall. So this distance of 1.2 meter, 0.3 meter and 1.6 meter we'll be able to observe in the top view projections, and this distance of 2.5 meters we will be able to visualize in the front view projections. So with this information, first of all, we are going to convert this real life situation into the orthographic projections of the oblique line, and we will be obtaining the front view projection between these 2 points, that is A dash B dash. We will also be obtaining the top view projection AB between these 2 points, and thereafter we are going to use the principles of rotation of the line in order to evaluate the true length of the distance between these 2 points or the objects in the front view as well as in the top view. And we will also be evaluating the angle of inclination of this true length with respect to the two reference planes over there. So let us start with construction of orthographic projections of this particular situation. Now, in order to draw the orthographic projections of this particular real life environment situation, we have taken a scale of 1:50, that is 1/50 scale. So reducing scale will be used in order to make a construction regarding the orthographic projections of the oblique line. So here a distance of 1 meter will be projected as 2 centimeter or 20 millimeter into the orthographic projections. Now we know that point A or the object A, it is lying at a height of 1.4 meter above the ground in the front view. Similarly, point B or the orange B or the object B, it is located at a height of 3 meter above the ground. So using a scale of 1:50, so this height, this will become 28 millimeter. That is the height of object A above the ground will be 28 millimeter. Similarly, the height of object B above the ground will be equal to 60 millimeter, and the distance between the projector lines measured along the wall in the front view, this will be 2.5 meters or 50 millimeter. So we are going to start with the construction of the projections in the front view. So the height of object A or the mango A above the ground, it happens to be 1.4 meter. So this we have observed in the front view. Next, we can draw a horizontal locus line over here, so that we will be getting the location of the point A dash in the front view. So A dash has been located 28 millimeter above the ground. Now let us proceed with construction of point A in the top view. In order to draw point A coordinates in the top view, we know that wherever point A dash is located, so we should be moving in the vertically downward direction over here. So onto this vertical projection line, point A will be located, right? So now we can see that if we are going to look at this particular object from the top, so first of all, as we are going to look from the top, from this side, point B will be encountered first of all, and once point B is encountered, we can see that distance between point B and the wall happens to be 1.6 meter. Then there is a distance or the thickness of 0.3 meter of the wall, and then as we move in the forward direction, point A will be located at a distance of 1.2 meter in front of the wall. So when we are going to look at this particular environment from the top, as we are going to move from this side, point B will be encountered first, then the wall will be encountered having thickness 0.3, and then as we move forward with a distance of 1.2 meter, point A will be available with us. So here the distance of VP and point B, it has not been provided to us. So we can mark this distance of point B locus line from the vertical plane as an arbitrary distance. So this we should keep as a smaller distance over here. So you can choose any arbitrary distance over here. So this locus line, it is going to provide me with the location of the point B top view over here. Now once I work out location of point B, I need to move forward by 1.6 meter. So 1.6 meter means 32 millimeter. So as I move forward 32 millimeter, my wall will be starting. So I know that the thickness of this wall happens to be 0.3 meter. So 0.3 meter means 6 millimeter. So in the orthographic projections, I am going to leave 6 millimeter further. So this is the wall projection over here. So 6 millimeter, it is the thickness of the wall. And after the wall, I know that if I move forward towards the observer, so I am going to move 1.2 meter in front of the wall. So 1.2 meter in front of the wall means that I am going to move 24 millimeter in front of the wall. So the moment I move 1.2 meter in front of the wall, so I'll be able to reach this point A over here. So it means that onto this locus line, the top view of the point A will be lying. So I also know that wherever point A dash has been obtained in the front view, on the same vertical projector line, I should be able to obtain the location of the point A projection in the top view. So this way, point A projection in the top view has also been located. So A dash has been located, point A has also been located. Now we know that if we have to locate point B dash in the front view, so the distance between the end projectors, it happens to be 2.5 meters measured alongside the wall. So we can see this is the wall. So measured alongside the wall, distance of 50 millimeter I have to draw. So please check. This is the distance of 2.5 meters or 50 millimeter. So from here, if I draw a vertical projector I should be able to obtain the projections of B dash and B onto this vertical projector line. So I also know that the height of this object B or mango B above the ground happens to be 3 meter. So 3 meter in the orthographic projections, this will translate to 60 millimeter height. So now you can see there is the height of 60 meter above the ground. So height of 60 meter above the ground, if I draw a locus line, so wherever this horizontal locus line, it intersects with this vertical projector line, I will be able to get the location of the point B dash over there. That is, the point B projected in the front view will be located here, which is 2.5 meter measured alongside the wall from left to right, and then it is at a height of 60 millimeter or 3 meter above the ground. So having obtained the point A dash and B dash, so I also know that wherever point B dash is located onto the same vertical locus line, my point B will also be located. Now I had already discussed with you that the point B, that is the distance between vertical plane and the locus line of point B, so we had defined as an arbitrary distance. So this is the location of the point B. So wherever I had drawn this locus line, so the point B will be located over here. So we can see that from point B, as we move along this particular side by 1.6 meter, we'll be able to reach the wall. After the wall, as we move along this distance by another 1.2 meter, we'll be able to reach point A. So point A is also located, point B is also located, so we can join A dash, B dash. So this is an apparent length. We have drawn it using a black color line. Similarly, point A in the plan, point B in the plan, they have been evaluated. So we have joined point A and point B using a black color line, and it is also an apparent length projection which is going to join the string, which is going to join objects or the points A and B. So with this, we have been able to convert this physical real life environment situation into the orthographic projections of the oblique line, in which A dash B dash, it is the elevation projection line, AB, it is the apparent length projection line in the plan, and both of these projections, they are not parallel to the XY reference line, so they are inclined to the XY reference line. So this is the case of projections of the oblique line. Now we are going to use the fundamentals of rotation of the line in order to evaluate the true length of the distance between point A and the point B in the front view as well as in the top view. So we know that whenever our apparent length projection in the front view, it happens to be parallel to the horizontal plane, so projections drawn through these 2 points onto the horizontal plane, that is in the top view, they will be providing us with the true length of the line in the top view. Here we have got the apparent length projections in the elevation, that is A dash B dash, it is inclined to the horizontal plane. So what we are going to do, we are going to rotate this elevation projection line in such a way that it becomes parallel to the horizontal plane. So how this can be done? A dash will be our needle point and or the locus point, and we are going to open compass is equal to the radius A dash B dash. So with locus or needle at A dash, we are going to rotate this line in such a way that this projection line becomes parallel to the horizontal plane. So the point B1 dash will be obtained, which gives us the horizontal apparent length projection in the front view. So having obtained this apparent length projection in the front view, now if we draw projections through these 2 points into the horizontal plane, so we will find that we'll be able to obtain the true length of the line in the top view. So from B1 dash, we need to drop a vertical projector up to the locus line corresponding to the point B over here. So this is the horizontal locus line corresponding to the point B. So through B1 dash, we have drawn a vertical projector onto the horizontal locus line corresponding to the point B. So this intersection of these two construction lines, so this is going to provide us with the point B1. And the moment we obtain this point B1 over here, so we need to join point A and point B1. So we have joined it using a blue color line. So this gives us the true length of the line. So the blue color has been used just to distinguish between the apparent length projection and the true length projection over here. So having obtained the true length of this line, which is going to join points A and B over here, now I can also evaluate the angle of inclination over here. So the angle of inclination of this true length with respect to the vertical plane happens to be angle phi. So the blue line, that is AB1, it is inclined with respect to the vertical plane at an angle of angle phi. Now, having evaluated true length in the plan and its inclination with the vertical plane, now we will be proceeding with the evaluation of the true length of the line in the elevation as well as evaluation of the true inclination of the true length in elevation in the orthographic projection. So in order to evaluate true length of the line in the elevation, what we have to do, we must ensure that the apparent length projections in the plan, they should be obtained parallel to the vertical plane. The moment we are able to obtain apparent length projections parallel to the vertical plane, so the projections drawn through these 2 points onto the vertical plane, they will be providing us with the true length of the line in the elevation over here. So now here we have got the plan projection AB, but this plan projection happens to be inclined to the vertical plane. So what we have to do, we have to rotate this black line AB, plan projection line, so that this AB projection becomes parallel to the vertical plane. So here with A as the needle point, we are going to open compass is equal to AB distance, rotate this plan projection line AB in such a way, we have to extend this curve up to the horizontal locus line corresponding to the point A over here. So once we rotate this up to the locus line of A, we will be able to obtain the plan projection line which has been converted to the horizontal plan projection line. And the moment we obtain this line AB2, this has become parallel to the vertical plane. So whenever our plan projection line becomes parallel to the vertical plane, so we need to draw projections through these 2 points onto the vertical plane, that is in the front view. So from point B2, we have to draw a vertical projector line over here and extend it till it intersects with the horizontal locus line drawn through point B dash over here. So this is the horizontal locus line which has been drawn through point B dash. So once we find out the point of this intersection of the vertical projector line drawn through point B2, so we will be able to evaluate point B2 dash. So having evaluated this point B2 dash over here, now we need to join A dash with B2 dash using a blue color line. So blue color indicates it is a true length over here. We have been successful in obtaining the true length of the line, and having obtained this true length, now the true inclination of this true length, that is A dash B2 dash with the horizontal plane. So this angle of inclination will be termed as angle theta. So angle theta can also be evaluated. Now in order to evaluate the accuracy of this construction, so we must ensure that and measure that A dash B2 dash distance, that is the true length distance in the elevation. So this must be equal to the true length distance in the plan, that is AB1. So once we evaluate that A dash B2 dash, that is true length in the elevation, it is equal to AB1, that is true length in the plan. If both of these distances they are equal, it means that the construction we have made over here, so that is an accurate construction, and we have followed the principles of rotation of the line appropriately in order to evaluate true length of the line in the elevation, true length of the line in the plan, as well as the true inclinations of this true length with respect to the two reference planes. So this is all for today. So I hope that through this discussion you would have understood about how we can proceed with the conversion of a real life situation into the orthographic projections of the oblique line, and then how we can use the principles of rotation of the line in order to evaluate the true length of the line in front view as well as in the top view, and the true inclinations of this line with respect to the two reference planes. So we'll be continuing with further discussion regarding few more cases on projections of the oblique lines in the coming lectures. So thank you very much. Thanks a lot.